Today we look at Laplace transform. We are given a function of t cos at. So we have t being greater than 0. It is defined. So we know that the Laplace of that function f of t shall have the integral from 0 to infinity, then exponential negative st f of t dt. So we shall have 0 to infinity, exponential negative st, and our f of t we have cos at t, so dt. So this one we are going to use, we want to integrate this one, so we shall use integration by parts. This one becomes u, and this one becomes dv. If you have u dv, this one is uv minus v du. So your u is exponential negative st, so du dt. Now it will be, if you differentiate, now it will be negative s exponential negative st. Then your dv, we have cos at. So to get v, we integrate cos at. So we shall get 1 over a sine of at. So come and replace. So we shall have to replace, have uv, have your u and v. So your u is exponential negative st, then v is 1 over a sine at, then minus, now the integral of, minus the integral of v du. V we got as 1 over a sine at. So 1 over a sine at. Then your du, if you make du the subject, it will be negative s exponential negative st. And you have dt. So you realize that this part, again you need to integrate by parts again. So you can have our equation, and write it. We have exponential negative st into 1 over a sine at minus, now the integral, these are constants, negative s and 1 over a, so negative s over a. We have sine at, then we have exponential negative st dt. So we integrate that one, this part, using integration by parts. So we shall have this one will give us 1 over a exponential negative st sine at, then you have minus, so minus, you can just leave it, so you have minus, minus, you have plus s over a. So your u, have this one, then you have dv to sine at. So we start with u exponential negative st, then you have v. So if dv is this one, so it means v, the integral of that. So it is negative 1 over a cos at. So we have negative 1 over a cos at, and we have minus, now we have v du. So your v is negative 1 over a cos at, then du was here, so u is this, so du we differentiate is negative s exponential negative s t, now d dt. So this one will simplify to this is 1 over a exponential negative st sine at plus this one, so it will be plus minus, so minus s over, we have s squared, then we have exponential negative st cos at, we have minus, so we have minus, so we have minus s over a, then the integral cos at, we have exponential negative st dt. So we find that this part is the same as the part where initially where we started with u with dv. We have uv minus v du. So it is the same as this part. So now we are going to collect on one side, because when we started our u was exponential negative st, then our f of t we have cos at. So if you collect it to the other side, of the equal sign, so you shall have exponential negative st cos at, they have plus, because the other is minus, so to their side plus s over a cos at exponential negative st, we have an integral here, is equal to, then this other part, so reaching at this point. So now we have this part, we have to simplify this part, so you can have exponential negative st is common, then we have over, now we can have s squared as common, so into bracket, so we have, now here we shall have a sine at, so that, and to cancel here we have 1 over a, and we have minus, so here we shall have s cos at. expand, we go back to that. So this side, this one is the u dv. Here coefficient is 1, so we should have 1 plus s over a. Then the whole of this is u dv. Now it will give us, now this other side we have exponential negative st over s squared is equals to a sine at minus s cos at. Now it means if you want to give integral u dv, so you are going to divide both sides with this coefficient, so that will remain with the integral. Now it means our final answer now for u dv now can simplify this over 1. We have a, then we have a plus s. So when you divide on both sides, so you should have a over a plus s, then times exponential negative st over s squared, then you have s sine at minus s cos at. So we have our integral there. So we need to apply the limits from 0 to now infinity. So the first one, if you substitute t from 0 to infinity, we shall have 0 minus, then we have a over a plus s, you have exponential 0 over s squared, then we have s sine times 0 minus s cos 0 times a. So it will give us 0 minus a over a plus s. This one is 1. This one will give you 0, but this one will give you 1 cos 0. Now we have 1, so negative s times 1, we have negative s over, now we have s squared. So a goes here, a times, so we shall have negative negative positive, so s over, if you expand a squared plus a as, where we have a squared plus as being greater than 0. So we have our final answer.